So happy to welcome you everybody today. Today we'll be talking about Azure Functions, how to start using Azure Functions, how to look on the architecture, what are the typical use cases, and how to set up monitoring for them to troubleshoot any problems you have. So today the presentation will be run by Radek and Adam. So Radek, if you could introduce yourself, who you are and what are you doing, that will be perfect.
Sure. So my name is Radosław Osiński, and I'm working for Microsoft as a cloud solution architect for CE region. And basically, I'm working mostly with the code, with the application refactoring on cloud, and Azure Functions is one of the topics we very often raise with the partners in terms of extending refactoring and making applications a little bit more elastic, but that would be more today definitely about this one.
All right, perfect. And Adam?
Yes, hello. Yes, I'm Adam. I'm the Chief Technology Officer at RevDeBug. We are creating with the team the end-to-end observability platforms, specially designed for cloud native applications, but actually, usable for even hybrid applications. So if you extend your legacy apps with cloud native elements, RevDeBug can help tie those two together and give you end-to-end observability there as well.
All right, guys, thank you for a brief introduction. So today we will be covering three topics. We start what is Azure Functions, what are the possibilities you could run Azure Functions, and we run a few examples. Later on, we move to architecture, so common or typical use cases that could be helpful, tips and tricks, so things that could be helpful for you, and also we show you how to monitor Azure Functions and how to troubleshoot them. And the last part will be about cost, what are different pricing models, and where you could look for cost optimization when you're running Azure Functions. So if you have any questions, you could type them directly in the chat or answer them or in the Q&A. We're answering them later during the talks. So Radek, the screen is yours. So tell us more. What are Azure Functions? Yeah.
Sure. So let me share the screen. Yeah, so basically that can be, for some of you, this topic might be kind of obvious because you already use that one, but definitely we would like to have you on all of the same page. And maybe we will add on top of that what you already know about this topic. So basically, let me drive to a few slides, then I will show you very simple demo how to run that one and what are the best practices around that one, because I have seen many ways that the developers starting working with the Azure function, but struggling with really executing that one in the very easiest way to validate that it is working and then extending the code itself. But maybe first thing first. Basically, the Azure function is for you should be the smallest execution part of the code that you're thinking about, the small functionality. Kind of microservices approach, but assume to that one because you need to think how you are executing the code, what is exactly the state of that, how you would like to trigger that one, and how you would like to scale this approach. And Azure Function can address many of the cases, and I will jump into the architecture of the cases a little bit later on. But first of all, definitely I would like to show you what are the possibilities and where you can put this function. So assume that you have a small functionality which you would like to execute with independent environment and separately using different languages, because you will see what kind of languages are supported. So basically, one of the things that I often have a discussion with the partners and with the companies who are developing the solution with Azure Functions, the first consideration is the limitation only to the cloud approach. And it is not really correct, because Azure Functions, yes, can be natively run on the Microsoft Cloud inside the app service, and the consumption plan totally scalable, but as well you can attach that inside the container and put on the container in the Kubernetes cluster, in the service fabric, inside the container instances, or any kind of ecosystem that can host the container. So this is basically the framework, not only the, let's say, cloud service that allows you to scale, but you can extend much more with this kind of approach. Obviously, if you would like to use the container version, you're going to the Docker Hub, using the base image and building on top of that your functionality, extending the feature and richness of this framework. If you are going with that with the Kubernetes, you need to look into the virtual nodes consideration and this kind of approach. And you can use, for example, container instances or any kind of other approach which is supported by virtual nodes as a separate something, as a nodes outside of the scope of the Kubernetes cluster. And if you are using the AKS, so Azure Kubernetes Services, this is just one button that you need to click during the creation cluster to make sure that the virtual nodes for the functions will be supported. But this is the case where we are thinking about the Kubernetes cluster and Azure Functions, that you are supporting scalability based that the load of your cluster. So it terms that, for example, your particular nodes are highly used, then you can add that one. But as well, what if you would like to use more event-driven approach? So basically, this is what exactly Azure Function is more designed for, event-driven architecture. And if you would like to do that, I really encourage you to look something which calls KEDA, Kubernetes-based event-driven autoscaling. This is the Cloud Native Computing Foundation support. And this project basically allows you to scale your work on the Kubernetes using the Azure Functions based on the events that come into your system. Not exactly only based only on your compute power. And this is basically game changer, in my opinion, in working Kubernetes and event-driven architecture. It can be complex, and really this is the big exclamation mark. Really think if you need that one, to do not overcomplicate your architecture, but in many cases it can simplify and resolve a lot of issues with really capacity and making sure that you are using the enough number of instances, and as well you are not booking the resources unnecessary and you need to pay for the capacity that you reserved, because in many cases when the capacity is not used, especially in cloud, is when the solution cannot be you cannot really assess how big load it coming to your system. And basically this is exactly when you're thinking about the event driven some additional events that flowing through your system. So definitely that concept is worth to look into. If you're looking into the Azure Functions, this is not only obviously the C#, because that is first thinking about the Microsoft technology, but definitely you can select the platform that you are using. So basically you can use the Node with JavaScript, you can use the Java, PowerShell, and Python there, that you can really extend and use the best language that you would like to. And maybe I will jump directly now to the short demo to show you what is happening behind the scenes and how it's works. So if we jump, let me open the Azure portal first to show you what is happening there and what I will be doing inside the
Radek, you are freezing a little bit.
Inside directly the Visual Studio. I use the Visual Studio Code because it have an extensions directly to Azure and directly to the Functions project. Yeah.
Yeah, Radek, you are freezing a little bit, so maybe if you could kill
But only the camera or the voice as well?
Voice and also
or screen.
And screen also is a little bit laggy, so maybe if you could kill a video and just keep the presentation, it should be fine.
Camera.
Yeah.
Okay, yeah. So let me check. I will, yeah. Good point. The screen back again. Okay, so let's continue with the share. Do you see my screen back again?
No.
Nope.
No.
I saw it in a sec. Okay. I think it's starting.
Okay. So give.
Okay, I see the screen.
Is it there already?
Yes.
Yep.
Okay, so let me continue now. What is happening here? So basically, what I can do, I just will create the new location for, let's say, particular project. Let's call it RevDeBug 3. So this is just a location when I would like to store my functions without any kind of Git repository attached yet. And now if you have an extension for the Azure perspective, first of all, you will find that particular projects are added here. So it should be loaded in a sec. And if it will load, then we can try to add new functions. So basically, if you click this create function or create function project, it should convert our function and add necessary files to have first definition of the function itself. I hope that it will not last very long because I open a new window. So maybe I will check if I have already. No. I thought that the previous window was there. Please bear with me a bit. Probably the connection of the internet is an issue a bit.
Yeah, it looks like a little bit laggy.
And probably that's why I'm loading all of the features.
Yeah. All right. So, any progress on your side, Radek? So, okay, maybe let's try. Let's try something different. So, let's go for a little bit to the presentation, to the architecture, and we jump back.
Okay.
Yeah. When the
yeah, that's good. That's a good point. When the function will load.
Yeah. All right. So
okay. Yeah. I could create the empty folder before that one. Yeah. So some of the. Okay. So we will jump back to the demo and I will show you the functions in a bit when it will load. But first of all, we will go to the architecture diagrams and show you a bit more. What are the cases that the functions should be used? Because oh yeah. Okay, so we can stop for now and I will show you because if it's loaded, it should go fast. So he asked me now if I should create a function project. And if you go here, let me check that again. It should load. I'm creating a function. Come on. Yes, I'm selecting the language that I would like to work. I will go with Node. And now it asks me what kind of template I should use for the function. So basically, the template allows you to define what kind of triggers. So I have a time trigger, HTTP trigger based on the queues, because the Azure Functions often use with the service bus or with the Cosmos DB with change feed. That depends on your particular scenario. But let us go with the easiest one. So HTTP trigger, RevDeBug. I will go with anonymous. And it creates me a project currently. So when it will be creating, I will log back again to Azure and show you on which Azure function project I will deploy that one. So basically, I got node functions on Linux. This is my naming. If you go inside the function app project and list of the functions, you will see that I have only one HTTP trigger. And right now, when I deploy the project itself with this function, you see that if I go to the files, you have see the index.js and folder for the HTTP trigger one RevDeBug function. Here you have the definition of the bindings and as well the function itself. So just triggering and sending some message, nothing complicated at the stage. So you just defining that one and extending the files. So currently, if I want to deploy my functions to the project, I just clicking on the file, deploy to function app, and it should load me the subscriptions that I have available. I will select my Microsoft internal one. He will try to find all of the functions project. You see there is a node functions, this Linux one, and I'm deploying that one. Deploy. And we just need to wait a bit when it finishes to be visible there. Yeah, so meanwhile, maybe we will jump into the architecture now, and when it finishes, it should take, I think, around 30 seconds because it's updating the packages and so on. Okay, yep. So we can come back to that one, jumping into the architecture. Okay, where is it? Sorry, here. Let me start from this slide. Okay, so as I mentioned, the Azure Functions definitely is not, and it basically the event-driven architecture is not something that is for every scenario, and you need to really rethink where is it worth, what kind of benefits it gives you, and then decide if the Azure function is better than a normal web application backend or any kind of time-based triggers or what kind of workloads are you using. So the most common scenarios that it is very worth to consider are mainly when you are working with the case like connecting two systems or doing something with the post-processing that requiring some queuing or maybe some bottlenecks that you're having and something post-processing activities, it's worth to consider the Azure Functions. So imagine the easiest and I think the most clarifying scenario is, for example, like you have the e-commerce store, someone doing the order, and basically you are not caring about if the order request and checking some, and for example, packaging order will go in 1 second, in 20 milliseconds, or in 1 minute, because in real life it change anything from you. So it's not point to really overload your application with this kind of order, because it will have an impact of your users' activities currently, but it is worth to extend from your application and have only separate process which will be executed only when the order will really come. So basically, this is the great scenario because you are having your web application, you pushing the item to the queue, let prepare me a package. And then when the item will come to the queue, like for example, service bus, the Azure function will raise, take this item, prepare all of the stack, put into the database and so on. So you are making sure that the preparation of the packages have no impact of your web application and interface of the ordering, especially if you have some let's say highly traffic like Black Friday, Christmas and so on. And it might be that, normally you do not see this behavior, but in very high season, it will be every milliseconds and every call to the database makes a difference for you. So this is the patterns for overloading your application with separate compute power, which is outside of your main hosting environment. Second scenario is often with the IoT. And in IoT scenarios, you are as well message-based or event-based. So Azure Functions in IoT systems, I often use, for example, for triggering any kind of alert. So when the metrics coming from the devices, we just filter this kind of messages and seeing if, for example, temperature didn't overload the maximum that we reached from last 5 minutes. And then if yes, we pushing that to separate queue, and then Azure Functions trigger that one. Those kind of activities maybe happened twice a day, or maybe often, maybe a little bit more rare. But it appears that it's no point to have the reserved capacity for this kind of scenario. But better have something which are paid based on the number of the events and time of the execution. Real-time file processing is as well scenario when you have some post-processing activities with the file. So basically, you are pushing the file to Azure storage, and when it comes there, then Azure Function use the blob trigger to really raise this file and do some activities. Let's say it pushing that to the OCR, recognizing the text, maybe transforming the paper invoice to the database invoice record. Those kind of activities. Maybe this is like a PDF, or maybe this is just text or JSON. Any kind of activity that you would like to do on the background with the files that you saved. Real-time processing, it's kind of similar to the IoT approach, but only to highlighting you that this is as well very used for the streaming purpose of the events. Because when we talking about the IoT, and I when mentioned you, I more highlighted the scenario when you would like to trigger the event from time to time. But here, it's more like, for example, you have some events for any kind of system going into your flow, and then you need to scale from one execution to 1,000 parallel executions. And Azure Functions can handle that because they can scale to thousands and even millions of the instances if that's necessary. So it can resolve your bottleneck issues with the capacities of really transferring the stream into any kind of activities of saving to particular locations, or maybe transforming the data. One of the scenario that as well few of companies that I'm working with looking into is transferring with OLTP system to OLAP system activities, and mainly, let's say, having the Cosmos DB with MongoDB API as a main database for web application, and then collecting those data based on the change feed. So basically the trigger that tells you what happened and what changed in the Cosmos DB database, and then transferring that into the data warehouse to preparing that for the analysis, or maybe even pushing that directly to the Power BI reporting or any kind of places that it will be displayed directly for the business. So those kind of activities, and as well, this scenario is related with the Lambda architecture, if you are familiar with this concept. With the streaming of something in real time to see what is happening inside the system or inside the traffic management system. scheduled activities, the Azure Functions have a time trigger. So basically, if you want to move from database from your local environment and would like to push the database, SQL database, to Azure with the minimal cost and really save a bit on that, you need to remember that using the single database does not have stored procedures. So you need to extract that one and push into kind of engine which allows you to have separate compute power for executing your scheduled task inside that one. So basically you can use the Azure function for that, just capturing your queries, connecting to the database every half an hour, or maybe often, that depends on the case, and using the same case to really execute those scenarios. And you can use Azure Functions, for example, as one of the cases. Next one, which as well is often used not only with container instance with the icon you can see here, but as well with the virtual machines. So assuming that you, for example, have machine learning algorithm close inside the container or inside the virtual machine, and you're running that, let's say, twice a day to collect all of the activities from your sales team. They, for example, they did some pictures, and you would like to analyze those data in daily basis. So it's no point really to have these virtual machines or container be running all the day waiting for those data. In most of the cases, you just sleep the database, just stop the database, or kill the container instance. And then when you receive the notification from the system, this is the time to really do the analysis. The Azure function raises the compute power to execute this particular process, and then separate function just listening additional queue where your virtual machine or container send the information that the process is finished, and then the function will kill this process with all of the compute power. So basically, this is how you can think about the scaling a bit your environment with the Azure Functions as a trigger for get up or get down your resources. And very common question is that, okay, I see let's say that I see some usage of the Azure Functions in my system, but what I can do to really work on that and how really extend those. So basically the Azure Functions have two scenarios with existing systems. One is, in my opinion, perfect way how you can expose additional functionalities for your SaaS application. So assuming that you are focusing about developing your own product with your features, and you will not taking care about all of the requests from your customers, because you would like to go in the global scale of the application, and you are focusing on the features that are the mostly used. So basically, you just giving inside your system ability to extend that via webhooks, and you using the Azure Functions functionality like an accepted option that the customers can add on top the functionalities. Take some data from your system, inject some data into your system, and extending functionalities based on what they really need without your engagement. And as well, additional topic is, okay, I have some application, but I would like to extend the functionalities on top of that, not exactly refactoring entire code. And basically, as well, the Azure Functions allows you to do so, because you can just use that as an API, directly calls via API to the function, or use some queues for the messages and storage to really extend your application and starting rewriting some functionalities or on the new approach with the event-driven approach, but not exactly stopping what we did currently and rewriting everything from scratch, because in most of the cases, you never have enough capacity to do so and enough time to really do not focus on the current production environment and start refactoring the code. So this is kind of case when you can extend something with the new architecture patterns outside of what you have currently. As you have seen previously, some triggers which you can use. So HTTP trigger, blob storage, and queue with the service bus is the most common. Lately, Cosmos DB and Event Hub as well taking into account. And you see as well separate for the IoT Hub, because the IoT Hub is a communication layer for the devices, but as well have inside the Event Hub. So basically using Event Hub and IoT Hub is very similar approach with the event-driven. And some tips and tricks about using the Azure Functions. As I showed you the Visual Studio extensions, I really encourage you to use the tools which supports the Azure Functions framework, because as you have seen how easy it was to really run that one from the local environment, and I hope it was deployed. Let me check. Yeah, deployment is completed. So I will go and refresh that one. You should see the function. Let me refresh entire page. Yeah, HTTP RevDeBug trigger 1. But let me refresh that because I clicked too many times, as usual. Didn't wait for the response. And inside that web application, inside that function, I have the particular functions that I used. I can see the code, I can test that one directly from that perspective and see what would be the response from that one. So if you will not use this kind of tools which support that one from the local development, definitely you need to package that as a normal application, do the deployment, and it is a little bit pain at the beginning. So definitely when you are starting, use as much support as you can, and then slowly you will understand a little bit more with the framework and so on. But definitely this kind of approach, as I showed you, I wanted to start with the very simple case, because very often companies does not know, developers does not know how to really start with the easiest way to start pushing some code here. So that would be the easiest way, and that is one of my recommendation. Second is definitely look into batch processing. You can use the Azure function to take more items from the queue than one, and that can reduce the cost of the execution. And this is as well important for you. As well, look into the static resources and HTTP client, because this is very common issue that if you use the HTTP client, it will be triggered for each of the functions. If you run thousands of those, it will cost you a bit. And in my perspective, the most important topic inside the event-driven architecture, and I think each architect who work a bit with event-driven will say that the monitoring of that without right processes is pain on the ass. So definitely use the tools that help you to really see what is happening, what is the map of the application, how they are connected, what is the execution. And basically you have in Azure some tools, but really I encourage you to look into as well in the RevDeBug tool, and Adam will present you something which in my opinion blows my mind first time when I see that one, how it works and how you easily can really see your code, how it was executed with any kind of bug, and it can be recorded. So Adam, I will give you the voice because I really love to see your demo.
Okay, thank you, Radek. I will take over the screen if I may. Hopefully you see all that. So yeah, but before I will actually start talking about the demo and showing you how RevDeBug can help analyzing and monitoring, analyzing problems with Azure Functions in comparison to other parts of your applications, I would just like to chip in and just say that if you would like to start with cloud native, especially serverless Azure Functions within your application, that if you're and you're not starting a new project, so you can't basically buy into that all just one go, the best course of action, and I've seen that in previous life and this as well multiple times, is extending your current application, and Azure Functions actually make it very easy to, offload some of the processing, for example, periodic processing, and I'll actually show example of that in a second. So make some periodic functionality, your application, triggers, and Azure Function, it will just lower the costs because you will not need to have some hardware to support all of that if it's not being used. And it also gives you this, this foothold to, create new functionality on the cloud for your, current project, and in a sense, use the strangler pattern. Yeah. So basically, just adding more functionality around your current functionality, and just maybe replacing, refactoring the current functionality as well. Basically in steps. And in a sense, strangling this legacy code and just making the application at the end a truly a cloud native one. So that's really works, and that's in most cases the business sensitive approach to do so, because rewriting everything from scratch oftentimes just doesn't actually work, at least from the business perspective. Okay, but going to the demo, what I will show you is error monitoring and analysis, scenario for a demo application that is exactly that. So there is some legacy parts, there is some Vue.js based UI that just works in one place, but there are some functions offloaded from this application to Azure Functions. So this particular Azure function I will take care of is a monthly reporting data processing function, which takes data from live sales Cosmos DB feed, process that a little bit and just puts that in a second report on the Cosmos DB instance. And then I will also show you how easy it is actually add RevDeBug to a serverless function. So let's go with the demo now. So let's assume for the demo we just receive an issue from one of our colleagues that says to us that try to generate a report, sales report for January, month of January, and include only the deals that are larger than $10,000, and the functionality haven't finished. From his point of view, at least, it didn't work. So he asked us to help us. Okay, so let's switch to a different desktop where I have a web browser open with RevDeBug interface, and I already have added RevDeBug to my application and to the serverless function. So here I can see parts of my application, the serverless parts of the serverless function, the two databases that the serverless function operates, and to diagnose that, I'll just switch to basically trace of every transaction, every distributed transaction that happened in my application in the last hour. Let's filter that to show only the errors in our Azure Functions. Okay, I have just one instance of that, so that's clearly my colleague doing. What I can see, of course, here is that the UI, the web part, and of course they are color-coded. Yeah? So the web part here called the Azure function. It triggered the Azure function, and then it connected to one of the databases. It opened the sales live database. Then it opened the live data. It queried the live data with the query for everything that have at the contract month of January. Then it actually opened the second database. So clearly something happened, and it inserted a record there. So from the user point of view, of course, it didn't work out, but the function have done something. Okay, so let's look at the error relevant here. So let's just go to the details here, and what we of course see apart from the stack trace, we of course see that yes, there was an error returned. The user haven't seen that. We haven't probably have that handled in the code, but this it's not a generic message. It's something definitely software developer put in the code. We see no records processed, so that's something that probably should be some records for January. So with RevDeBug, and that's actually what's unique about RevDeBug, in the outlook of the other observability platforms, is we can actually see inside that function execution of this function and see the recording. So basically a statement by statement or line by line recording what happened there. So we see the error we are just basically at the end of the recording. So we see the error of the processes, and with the arrows I can actually go back in time, statement by statement here, and I can verify what was executed and what data was causing this execution. So here I can definitely confirm that the records process was equal 0. So okay, that's not what we want to see in the application. So why happened? Yeah. So let's just trace a little bit back in time. I see the insert that happened to the reports database. It's definitely wrong data because there's just zeros there. I will skip all of that, all of those clauses here. I will just directly go to end of the processing that happens before that. So we have a loop that processes the data that was read from the database, and I'm at the end of this loop. So we'll just go back in time. So I see that okay, the last record was definitely not processed because the amount wasn't large enough. If I would just go those lines of code above, I will see okay, that could happen because that's 9,000. We know that 10,000 was the amount. Okay, that was Germany. Okay, so of course I can search basically here at this event list, but at the end of the day I will also stumble upon this record, and this is actually something that was wrong because it's larger than 10,000. But if I would just go forward in time, I will see that the condition wasn't met. So let me search for the mean values value, and I will see that it's being set as a constant value here. So we received that from the trigger that happened that, and of course I will see also that all of the records pulled from the database were not meeting the condition, and this value is clearly wrong. It's not 10,000. It's 1,000 times larger. Okay, so let's look at the UI code that actually executed that, because I have added RevDeBug there as well. So this error basically is propagated to the UI as well. So I do have recording of the call that was made from the UI part, and this is a Vue.js application. So if I'll just go back in time from the end of this call to this moment where parameters are being actually prepared to post to our Azure function, I will see that indeed the parameter was sent in the value was wrongly sent, but I see that basically the application assumes that the user enters the thousands of dollars into the text field, and definitely my colleague have entered the USD amount as basically a dollar value, not the amount of thousands. So in this case, it was actually a user error in a sense, or maybe we just have not added additional guards and validation into our UI layer, so you can actually fix that. But what I wanted to show you in this very short demo is how easy it is to actually track the real execution and the real data that is being processed by our application with RevDeBug through all of those layers in a distributed application. And that's how you can actually use RevDeBug with your applications. Introduce Azure Functions or other cloud native elements to your application. You can just use RevDeBug to track those problems that happens also between those parts of the system and inside those parts of the system to better understand what happened there and why maybe this some errors are happening. Yes. Okay. So just going back to the demo. Just also wanted to show you and encourage you to play with RevDeBug. It's very easy to deploy. All of the data RevDeBug stores is actually where you run the RevDeBug, so you can actually deploy RevDeBug on your own Azure tenant using the Azure template we provide. So it's basically one click, and you can get the server running in minutes. And Currently, for Azure Functions, we support the C# and JavaScript languages, more languages coming soon, because we actually support more for other parts of the application, but Azure Functions currently have those two covered. And let me switch to another desktop just to show you how easy it's actually to use RevDeBug and to add RevDeBug to your Azure function. And here I have the the example of this JavaScript Azure function I was just showing you. So, and have some steps, and that's all in the documentation, so you can look that up. But basically, what you have to do is just 4 steps to use RevDeBug. Apart from running the server side, just add our npm package registry. You have to, of course, install the RevDeBug module as well. You need to create a small configuration file, and I have it here. So you basically have to tell RevDeBug how to name your application inside the interface, where your server is being located. That you want to have performance metrics, which I will show you maybe in a minute, and of course that the type of the application is a function, basically, and of course which files to have RevDeBug to instrument. And the last step is in your build pipeline, in your deployment pipeline, you also have to execute the npx revd script to instrument your application. I have added that to actually my build script that the CI/CD server is just launching, so it installs the npm packages, it does the instrumentation, deploys the function, and we do some cleanups at the end just to be sure, and that's all. And after that, the RevDeBug will start monitoring and tracing and error recording of your application. So that was a very short demo I wanted to show you for monitoring and error, actually reporting and error analysis for Azure Functions. And Radek, back to you for the pricing model of Azure Functions.
Sure, let me share my screen. Tell me when it will be visible.
It's live.
Okay, great. So yeah, basically everything what is dynamic calculated, it gives, let's say, question mark how it priced and how you calculate that one and what you need to consider. So basically, one of the advantages definitely of this option is no need to manage the servers, just putting that on the container or just the app service to run that one, and it can be basically consumption-based approach. And if you have consumption-based, you need to take into account number of the executions and time of the executions. And basically using the consumption-based and this kind of approach with Azure Functions allows you to go with some features or particular elements faster to the market. And basically, this kind of consumption base, it's not maybe everyone feels comfortable with that one at the beginning, definitely. So there are kind of additional ways how we can model the pricing and work with that one. Because I mentioned the consumption plan allows you to work with your application, and 2 issues. One issue is the cold start, and cold start means that if you are not using the application, first execution after every 20 minutes of not using the Azure Functions means that first execution will be a little bit slower. A little bit, I mean, even let's say 3-4 seconds. Maybe it's not accepted from your case. And as well, consumption plans generated you let's say unknown of the cost at the end of the month. So if you would like to, at the beginning when you are working and do not feel comfortable with that one, you are creating the service plan and put the on the service plan level, you putting the cost. So it means that you are fixing your number of the executions. So you exactly can, you will know how you much pay because you are selecting particular plan, let's say for $120 monthly. But first of all, you are locking the resources. So it means that even if you are not executing the functions, you will pay for that one. But if you are executing too much, not all of the execution can handle, let's say, and you can have, for example, for HTTP trigger the timeout. So if you have something on the middle when you can accept the unknown state of the final cost of the function based on the number of the executions, then you can go with the premium plan, because premium plan book only one core for warming up the function, so you do not have the cold start filling. And as well, you are using the auto scalability for the consumption base. So instantly you can run thousands of the instances if you are need that one. And if you are using the function, definitely worth to look into something which calls API management, which allows you to expose your API to your customers. So assuming that you have the serverless approach and execution per functions, and you can charge the customers using the API management as well per execution of your function and calculate that one. And about this performance monitoring and see the really pricing, how it works, definitely you need to know what are the times of the executions. And definitely Adam can show you how it looks in the RevDeBug in terms of really predicting your costs with some metrics inside the RevDeBug.
Yes, so I will hijack the screen once again. Thank you. Yes, so exactly. So yes, Azure Functions, as Radek said, you basically pay for the execution time and of course execution number. And for serverless function RevDeBug, of course, basically any observability platform in this regard, it's no different. We of course also can show maybe let's go to the global first, the times that the execution takes, and of course the amount of the execution that happens. So very easily using the dashboard, or I will go also to particular traces. RevDeBug can help, of course, with identifying the slow running functions and those functions that are being used the most. So going from the global, we can of course see actually for the whole application, not just the functions, how it behaves, how long those endpoints and services are running. And for particular services, and I actually have the service here selected, I can see the particular function. I have 3 here, particular function, how well it behaves, how long the execution time goes, and of course the slowest ones and the most used ones. So basically actually multiplying this value over this value, and of course about the dollar value of the Azure function can basically predict you how costly it will be. And of course you can very easily identify functions you probably should optimize. And for example, here I will just check the data integrity, is the largest one here. So I'll just go to the trace, I will sort for the duration, and I'll just check the Azure Functions service here, and of course check data integrity is the first one. I can see actually all of that, and at the glance of that I can see the error that was done here. And this is one of the tips Radek said about the considering the outer loop. Here I can see one of the functions are actually calling the second function as well, and it's waiting for it. I definitely see that it's waiting for it. So rewriting that to use a durable function, durable Azure function that will not wait, just offload the execution and wait for the callback would be just better idea here, because I will just save all of that execution as well. So RevDeBug can definitely help also in identifying those places where the optimization is in place. And I think we are coming to yes to an end of the presentation. Hopefully you gain something from that, and I think we'll can get some questions. I think Piotr, you will moderate the questions. Yes.
Yes, I have first question. So question for you, Radek. Are you with us?
Yeah, obviously.
Yeah. All right. So what are the common problems I should know about when running Azure Functions? So probably where should I start, or what should be what are the typical problems? Oh, let's start with that. Yeah.
You know, the main problem, in my opinion, is not the running, let's say, one or two functions, but complexity of planning and architecting and entire environment. And you need to really consider how you chain those functions. Do you need the framework like durable function for that one? Because this is what Adam showed, the chaining the function and double paid is very common issue. Or kind of any places where you thinking about the code like, okay, it's just execution, but before you just kind of pay for the service, but here you are paying for each second of the execution. So you need to think from the beginning how you really refactor in the code in terms of cost optimization and debugging mode of that in terms of the, let's say, entire flow function by function and how to look into that, because the cost is the one, but definitely the debugging approach to that one and what exactly we are trying to highlight on this webinar. The issue with right monitoring and right considering to really speed up your development, because people does not often see the monitoring as something as speed up the work. It's seeing something as a DevOps approach, but in my opinion, if you would like to be a good developer and speed up the work with the event-driven approach, the first thing with the first function, it should be attaching the good monitoring.
Yeah. If I can add to that, actually, so one common thing I've shown and my team also have seen is, if you migrate from the classic or almost monolithic application design to this distributed one, people often carry on some patterns they learn for years, and one of those patterns is to basically limit in one module the data access. So basically encapsulate the data access in one place. You have some data access, classes and the like. And with the cloud native approach, of course, you do not create a one Azure function or microservice for data access, because this will just add more latency to your system. You still can make that in the code. You can make some libraries for that, but Azure Functions will just connect to the database by themselves. So they will not connect to some other service to get data and process that, because this will just add latency and of course will add cost. So that's also one thing to consider. Like Radek said earlier, you have to think about also about the patterns and the practices you carry on from the years of development of monolithic applications. You have to think about them also, whether they are applicable or are there better patterns in cloud native approaches.
Totally agree.
Another question for you, Radek. So what was the most hardcore thing you did with Azure Functions? So maybe some problems also. So I remember our experience.
So basically the experience which we had in the previous company and previous setup, I as well had with one company. Let's say the most hardcore architecture that I did. One of the case, and second case was entire system for the managing the water pumps globally, with connecting with the IoT Hub and Azure Functions to stream the data and managing that between the web application and CRM system. So that was kind of funny, because the entire Azure Functions was responsible for setting up the communication, the water pumps, because you can change the status of the water pumps, reconfigure that one, and so on. So basically, we use the queues and Azure Functions only to highlight the entire layer of the flowing of the configuration, the device's configuration, and that works in milliseconds, even with few queues on the way.
All right,
you are muted.
Yeah, I know. Another question: how can I control costs when using Azure Function? I think we mentioned this already. So if you could repeat, Radek.
Yeah. So first of all, definitely when you are developing the Azure Function and you just starting, use the reserved capacity for the plan, and you exactly know how much you will pay, probably a few dollars on the smallest plan. But going further, to optimize the cost with real environment, you need to monitor how many functions is executed and how long, to have some statistics for yourself for that one. And definitely you need to have some alerting of the number of the queue execution, because you need to remember that you could do any kind of issue and have some loop which executes the function over and over, and you will pay for any kind of executions. So any kind of alerting that gives you information, listen, that was executed 20% more than last week or 20% more than last day. Look into to make sure that you will not surprise with the invoice.
All right. Sorry, my cat.
Yeah, maybe I can add one thing, because I also actually had some talks about that. Yeah, so if you actually go with the road that you extend your current application with Azure Functions, you might actually stumble upon the standard limits for the cross domain calls. So you basically can get those calls to Azure Function actually blocked by Azure if your application is running in your data center or your client's data center. And one important thing is, some developers actually do those errors to just not disable this security measure entirely, but to configure it properly, because in the case if you disable that entirely, anyone basically can call your function. Yes, and there are some basically robots that are crawling the DNS space, and they can call your function multiple times.
But Adam, to add on top of that, even lately I did the configuration that on top of the Azure function you can add natively the Active Directory. So you need to have a principal and passwords to that one to really connect to the Azure function. So this is as well good best practice for that one, to add the security as this native approach with the Active Directory, which you can see on the left panel to adopt.
Yeah, exactly. Yeah. So just trying to thinking about that. This part of your application might be actually out there, might be accessible publicly. So secure that. Make that conscious decision to actually have this authenticated, like Radek said. It's also good practice, and will shield you from unnecessary costs that might be there. Yes, because
Yeah, guys, because our time is almost up, before I sum up, a question for you, Adam. So what are the languages RevDeBug is supporting, and how I can start using RevDeBug? So
yes, okay, thank you, but yes, so RevDeBug works natively with C#, Java, JavaScript, both in the front end and the back end, and Python, starting from the stable version 3.8 to app. For Azure Functions, right now we support only 2 of those platforms, so C# and JavaScript, basically JS, but more are coming soon. And we actually have some a roadmap for other platforms overall, support for other platforms as well. So and all of that is described on our webpage manual. So RevDeBug.gitbook.io. That's it's basically holds all of that, and also there are steps how to start with whatever language you use, how to start with RevDeBug and monitoring that. So and of course, if anyone have question, can also mail me. I'm just adam@revdebug.com, and I will also gladly respond.
all right, guys, thank you for today. So just summing up, architecture. This is the most common problem I can hear, and you also referred that to this in the presentation. So basically understanding what are the use cases, what are the limitations, and also what are the pros of using Azure Functions, or basically generally serverless approach. This is top 1 priority. Another one, it's monitoring. It's super easy to run functions. It's super easy to deploy them. But when you don't know why they are broken, or why they are not working, or where are the issues. It could result, in bad experience for users, and also it could increase cost for your functions. And just to end, if you want to start using RevDeBug, you could join for free and let us know if you are what do you think. So thank you for today, guys. It was pleasure to hear you today and see your presentations. So thank you. All right, guys.
Thank
Thank
you.
you.
Too.
Thank you.
Have
Bye.
a nice
Day.
evening. Bye bye.
Bye bye.